In this session, we will learn data flow in MapReduce using word count example. When you learn Java programming or other programming, you start with hello world example. When you learn MapReduce, you start with word count example. It is the simplest example in MapReduce. I have taken this example just to explain the concept of MapReduce. In the later sessions, we will see more complex examples. So let's see how this MapReduce program works. The problem statement here is to count each word in the given file. That is the word count example. The most important thing in MapReduce is that everything is expressed in the form of keys and values. Mapper function takes keys and values as input parameters. Map output is also keys and values. Reducer input and output is also keys and values. So in MapReduce, data must be expressed as keys and values. The problem solved using MapReduce can also be solved in the traditional way. But you won't get the advantages of distributed computing. So from now on, you need to think in terms of distributed computing. And also you need to think in terms of keys and values. Whenever you are given a problem to solve, and if you are using MapReduce to solve that problem, then you need to decide what has to be the key and what has to be the value. That is, the developer has to decide what has to be the key and what has to be the value. Keeping this in mind, let's start with the MapReduce program. In MapReduce program, we need to specify the input file that has to be processed. If a directory is specified, then all the files in that directory will be taken as the input data. Also, we need to specify input format in our MapReduce program. The job submitter uses this input format and computes the input split of the file. All the code to split the file is available in the subclass of the input format. Input format is just an abstract class. The subclass is called file input format. We are using this sample file just to explain the concept of MapReduce. Otherwise, usually the file size will be in hundreds of MBs or in GBs. As said earlier, input split is just a reference to the already existing blocks in the HDFS. Since we have to count each word in the input data, we will choose word as the key and count as the value. In our example, the input file is divided into 3 splits. So 3 map tasks will be created. That is, 1 map task for each split. All these map tasks will be running in parallel on different data nodes across the cluster. Now we need to read the input split. This is where record reader comes into picture. Input format defines the record reader to read the data from the input split. The record reader reads the input split and passes the input data to the mapper function. Mapper function is also defined in our MapReduce program. Mapper function parses the input data and emits keys and values. As said earlier, here words are the keys and count is the value. So the mapper will emit numerical 1 for each word that it encounters. In our example, the word what is encountered first. So the key is what and the value is 1. Next it encountered is. So key is and the value is 1 again. Next key is Hadoop and value is 1. Again it encountered the word what. So the key is what and the value is 1 again. Similarly, all the mapper function in each map task will process the input split and emit keys and values. Now the map output has to be partitioned. Let us see how it is partitioned. Number of reducers configured in our MapReduce program is taken into account to create partitions. First, the map output key is hashed using a hash function. This will return a constant value. Then the modulo of number of reducers is computed on this constant value. In our example, we have configured 2 reducers. So modulo of 2 on any value will always result in either 0 or 1. As a result, all the keys whose remainder is 0 belongs to first partition, and all the keys whose remainder is 1 belongs to the second partition. Finally, all the map outputs are divided into 2 partitions. So the number of partitions will always be equal to the number of reducers. By this process, same keys will always end up in the same partition. It also means that all the values of a particular key will always end up in the same partition. In our example, the output key what is in the second partition of all the map tasks. After the map output is partitioned, each partition is sorted independently. An important point to note here is that the partition is always sorted by key. The partition is never sorted by value. It is always sorted by the key. After sorting, shuffle and merge comes into picture. In shuffle and merge, each reducer will take one partition from all the map tasks and merge it together. In this way, all the values of a particular key from all the map output will always go to the same reducer. So the important point here is that partitioning and shuffling will make sure that all the values of a particular key does not go to different reducers. Rather, it goes to the same reducer. In our example, all the values of the key what has gone to the second reducer. Since the second reducer got all the values of the key what, it can compute the total count of this word. Similarly, all the reducers compute the word count and store the final result in the HDFS. The output path is also configured in our MapReduce program. So if you see from a bigger point of view, you will see that the logic in the mapper and the logic in the reducer is used together to solve a given problem. This is how a MapReduce program works. This is how data is divided and processed in MapReduce. Now you might be clear on why you need to think in terms of distributed computing and why you need to think in terms of keys and values. That was all about word count example. Thank you for listening to this session.